Hi, I'm Sydney Cleveland, and the first presentation that I am working on is the history of the periodic table, more so of the periodic trends. There are 6 major trends that I will be talking about in this presentation, which include electronegativity, ionization energy, electron affinity, atomic radius, melting point, metallic character. So for the definition of a periodic trend is a regular variation in the properties of an element with increasing atomic number. So the first trend I'm talking about in the presentation is electronegativity. So for the from left to right of the period of the elements, the electronegativity increases. So if the outer shell of the atom is less than half full, then it does not need too much energy to lose an electron. And from the top to the bottom, electronegativity decreases because the atomic mass increases going down the group. Thus, there is a distance between the outer shell, electrons, and nucleus. And important exceptions of the above rules include noble gases. And these noble gases are lanthanides and actinides. These gases have a complete outer shell and usually don't attract other electrons. Oh, and by the way, when I say outer shells, it's the valence shell of the atom. The next one is ionization. The lower the energy, the more readily the atom becomes. And this is an opposite of an electronegativity. Therefore, the higher the energy, it is unlikely to become a cation. The right side has more ionization energy because the outer shell is nearly filled. Ionization increases from left to right due to the outer shell stability. This also requires the energy to remove an electron from its gaseous phase. So as you can see on the picture here, ionization increases going across the period and goes down the group. I hope I'm saying that right. I'm pretty tired. So electron affinity increases left to right and decreases from top to bottom. So when I say increases left to right, it is caused by the decrease in the atomic radius. And when I say it decreases from top to bottom, it is caused by an increase in atomic radius. Atomic radius trend decreases from left to right within a period and increases from top to bottom with a group. So when I say it decreases from left to right, it is caused by the increase in the number of protons and electrons across the period. And when I say it increases from top to bottom, it increases caused by electron shielding. Melting point trends. Decreases from left to right across the period which is caused by the decrease in radius of the atom that allows the outer electrons to ionize more readily. And most nonmetals don't need a high melting point. Melting generally possesses a high melting point for, I assume, most to all metals. And the non-metal carbon possesses the highest boiling point of all the elements. The semi-metal boron also possesses a high melting point. So in the picture here, this is a key to which is the melting points for all of the elements. So the red is the highest and the blue doesn't have one. Metallic character trend. Characteristics decrease from left to right across a period, caused by decrease in radius of the atom that allows the outer electrons to ionize more readily. Characteristics increases going down a group. Relates to the ability to lose electrons, and non-metallic character relates to the ability to gain electrons. The electron shielding causes the atomic radius to increase, thus the outer electrons ionize more readily than electrons in smaller atoms. And here is my works cited. Thanks for watching, you guys.